Testing, testing. That's just a delay. Okay, here we go. Now let's get started. All right, we are covering 4-6, which is continuing ratios and proportions, and it's talking about scale drawings and models. This is probably the way you will see it most often when you're dealing with proportions. Okay, so here we go. So a scale drawing or a model is used to represent an object that is too big or too small to be shown in its actual size. The dimensions of the object on the scale drawing or model are proportional to the dimensions of the actual object. So anytime that you see talking about a scale drawing or model, your brain should automatically think proportional. I can set up a proportion to possibly work this problem. Okay. The scale is the ratio of the size of the model to its actual size. So the scale, which is also the scale factor, which we'll talk more about on the second page. Okay, I always think about that as SF equals model over actual. And we will talk about that more on the back. Okay, so the scale, which we wrote right here, that is model over actual. And remember that we're writing all of our ratios with the fraction bar. A scale can have the same units or different units. Okay, so it could have the same or different units. You can use a scale to find a missing measure on the model or the actual object. Simply set up and solve the proportion. So here we go. Let's take a look at this. We're going to jump down to number 3. Okay, it says a model car uses a scale of 2.25 inches equals 3 feet. That is half of my proportion. The scale is already half of my proportion. Okay, so I'm going to have my word ratio, which is model over actual. So I'm going to have this 2.5 inches. Obviously, that's not the actual car. So that's going to go on top. Now, it's not 2.5, it's 2.25. Now, what's nice about this is 1/4 is the same as 0.25. Anytime that it is an equivalent decimal, write it. It's much easier to work with decimals than it is fractions, but you don't have to. So we have 2.25 inches goes with 3 feet equals. So this half is the scale part. Remember, what's on the top on one side must be on the top on the other. And then it says that the model is 14 inches long. So since it's talking about the model and the model is on top, the 14 is going to go on top here. And then it says, what is the actual length? So I'm looking for the actual length. So my X goes in the bottom. So the X is being the actual length. And now we solve this proportion. So I multiply diagonally and I get my equation, which is 2.25x equals 14 times 3. And yes, you get to use a calculator. So we have 2.25x equals 42. And then I divide by the 2.25 to both sides, and we end up with 18. Now, when I look at this on the calculator, you'll notice that it's the 0.6 repeating. That means it's 18.6 with the bar over it, and this is feet. You have to make sure that you have the units. You could also write this as the fraction, 18 2/3 feet. Both of these are acceptable answers. Okay, looking at the next problem, we're going to jump to number 6. It says a scale model of a new building was created for approval by the city. The scale of the model is 3 inches to 20 feet. If the model is 5 feet, oh, wait a minute. Model here was in inches, but now the model here is in 5 feet. We can't do that. We have to change this to inches. We have to figure out what is that in inches. So 5 feet, that means I've got to do 5 times 12, which is 60 inches. And now I'm going to use this number in my proportion. So I'm going to have inches to feet. So I'm going to have 3 inches to 20 feet equals 60 over X, because I'm looking for the actual building. So that is my X. And now we cross multiply diagonally, and solve. So I have 3x equals 1200 divide by 3. And x equals 400 feet. Whew, my pens are running out. I have to see if I've got another set. Okay. And next problem, going on to the back. Next example will work together. Let's look at number 9. Okay. The reason I'm doing number 9 is because, in all honesty, I don't know what 8/15 is. And if I plug it in, because I'm looking at it and I'm like, okay, I want to change that fraction. But if I do 8 divided by 15 to figure out what that is, it's a repeating decimal. That means I cannot change it to a decimal. I have to leave it as the fraction. So here we go. We got to work this sucker as a fraction. All right, so let's go with this. It says the tiny statue of Tom Brady is 2 8/15 inches tall. Well, that means if it's the statue, that means this is the model information. Okay, if the statue uses a scale of 1 inch equals 2.5 feet, what is Tom Brady's actual height? So that's going to be my X. So I'm going to have model over actual. So I'm going to have 1 inch to 2.5 feet. And then now I'm going to change this mixed number to an improper fraction. So that's going to be the same as 38 over 15. Because 15 times 2 is 30 plus 8 is 38. So I'm going to have 38 15ths over X. And yes, you're like, wait a minute, I can't have a fraction in a fraction. You're right, but this is a proportion. This is an equation. We're now going to solve this problem. So I multiply diagonally. Okay, which means I may have to change this 2.5 since I'm dealing with fractions. That's going to become 5 over 2. So now I'm going to have X equals 5/2 times 38 over 15. And now we simplify. 5 goes into 5 one time, 5 goes into 15 3 times, 2 goes into 2 one time, 2 goes into 38. I think it's 17. Oh, 19. 19 times. So end up with X equals 19 over 3, or 3 goes 6 1/3 feet, or that's 6.3 repeating feet. Any of these are acceptable answers. Okay, now that was finding a missing measure. Now we're going to talk about, given the information, we need to find out what the scale is, what the scale factor is. But excuse me. So we need to remember that the scale, which is also called the scale of a drawing, to find the scale, let's come back over here. Write the ratio of the model length to the actual length, and then simplify the ratio. So the numerator is a 1. So divide the numerator and denominator by the numerator. That's one way you can think about it. So you always you would like it to where your numerator is a 1. So to do your scale factor, it is always the model over the actual. All right, so if I'm looking at number 11, the drawing length, that's my model. So I'm going to have 9 inches over the actual length, which is 45 inches. I'm sorry, 45 feet. And now we simplify. I'm going to divide by the numerator. What's my numerator here? 9. So I divide by 9 to both, and that gives me 1/5. This is my scale, which is going to be 1 inch equals 5 feet. This is my scale. All right, let's work another one like this. Okay, so we've got a fraction here. But if I go into my handy dandy calculator and I do 2 divided by 5, enter, that gives me 0.4. So that's an ending decimal. So I can change this to 6.4. So I'm now going to have 6.4 meters over 120 kilometers. Now remember, we want to divide by the numerator. So I'm dividing by 6.4 to the top and the bottom because I want the top to be a 1. I want the numerator to be a 1. Oh, you can't barely see that. I think I need to turn the lights off. I think it's just too bright outside. I'll have to change pins. All right, so we're dividing by 6.4 to everything. So I'm doing 120 divided by 6.4 because I know 6.4 divided by 6.4 is going to be 1. So I have 1 over do that division, and I get 18.75. Now I've got to remember my units here, meters and kilometers. So I'm going to have 1 meter equals 18.75 kilometers. And there's my scale. All right, your assignment is to finish the notes and the classwork homework. Have a great day.